Alright, yesterday we did a factoring review over our quadratics because I told you guys that we're going to move on to factoring higher degree polynomials, right? So that's what we're getting into today, is factoring those higher degree polynomials. So we'll split the notes up into a couple of sections. So today, and then probably Monday, we'll be able to finish them up. So today is factoring polynomials, part 1. So like we've talked about before previously, we factored quadratic polynomials. We reviewed that yesterday. You can also factor polynomials with degree greater than 2. Some of these polynomials can be factored completely using techniques you have previously learned. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. So it's pretty much you just keep factoring it till none of your polynomials can be factored anymore. So essentially what that's saying. Does that make sense? That's when it's factored completely. Okay? Any questions about that?
No.
Can I move on or no?
Yes, no.
Okay, moving on. So, factor each polynomial completely. So letter A, x cubed minus 4x squared minus 5x. What's the very first thing we always need to look for when we're factoring any polynomial? GCF, right? Always look to see if there's a GCF that I can factor out first. So looking at my coefficients, I've got 1, negative 4, 5, negative 5. Are there any numbers that would go into all three of those besides 1? No, so I can't factor out a number. Do all three terms have any x's in common?
Yes.
Yes, how many x's?
1.
1x, right? Every single one of them has at least 1x. Yes?
Can we turn on phone class? I can't.
Yeah, I can do that. Make sure we're not falling asleep. So, what can I factor out here? X. Is that my GCF?
Yeah.
Yes, it is. So, x times what would give me x cubed?
X squared.
X squared. X times what would give me negative 4x squared?
Negative 4x.
Negative 4x. X times what would give me negative 5x?
Negative 5.
Negative 5. Always look for a GCF first and foremost. Okay? So I've got two polynomials now. I've got x, that's one of my polynomials. Another polynomial is x squared minus 4x minus 5. Can either of those be factored further?
No.
Are you sure?
Yeah.
Are you sure?
Yes. Second.
Can't you
Oh, we can attempt to factor here.
the box thing?
Yeah, our t-chart. Let's try our t-chart for x squared minus 4x minus 5. So let's go ahead and draw some parentheses. What's my variable that I'm using? X. I have a minus sign in front of my c value. Does that tell me I'm going to have same signs or opposite signs? Opposite. So one's plus, one's a minus. Everyone okay and with me so far? Now I can create my t-chart. What goes in the first top box?
5.
Negative 5. Second one? Negative 4. I'm looking for two numbers that will multiply to give me negative 5, add to give me negative 4. So what are two numbers that multiply to give me negative 5?
Negative 1 times.
What'd you say?
Negative 5 and 1.
Negative 5 and positive 1. Those multiply to give me negative 5, right?
Yeah.
Let's add across, see if they give us negative 4. What's negative 5 plus 1?
4. Negative 4.
Negative 4. Are those the two numbers I want?
Yeah.
Yes, they are. Does it matter where I put them in my parentheses?
Yes.
Yes. They have to be with the correct sign. So I get x times x plus what?
1.
1. Because my 1 was the positive. Times x minus
5.
5 because my 5 was the negative. Does that make sense? Okay. So now I've got three polynomials. I've got x, I've got x plus 1, and I've got x minus 5. Can any of those be factored any further? They cannot. So this is now factored completely. And that's my answer. Does that make sense?
No.
Does that make sense for us?
It did.
Okay, can I erase and move to B? Letter B. 3y to the 5th minus 48y cubed. It's the very first thing I need to do when I'm factoring polynomials. GCF. Is there a number that goes into both 3 and 48 besides 1? 3, right? So I can factor out a 3. Then how many y's do they have in common? Y cubed, right? They got 3 y's in common. Each term has at least 3 y's. So my GCF that I can factor out is 3y cubed. Does everyone see that? 3y cubed times what would give me 3y to the 5th? Y squared. Remember, when you multiply, you got to add the exponents. So my exponents there have to add up to 5. 3y cubed times what would give me negative 48y cubed? Negative 16. Everyone okay with that?
Yes.
So after factoring out my GCF, I've now got two polynomials. 3y cubed and y squared minus 16. Can either one of those be factored further? I hear yes, I hear you, I hear no. Those of you that say yes, what do you think can be factored further?
Can't you factor it down to get the y squared, like to y's plus a variable or minus?
How would I do that?
I forget what it's called, but it's where you like put 2. And then
It's one of our special cases, isn't it?
Yeah.
Yeah, because can I take the square root of y squared?
Yeah.
Can I take the square root of 16?
Yeah.
Is there a minus sign between them?
Yeah.
Yeah, this is a difference of squares.
That's what it's called.
Do I need to bring down the 3y cubed?
Yes.
Yeah, that's part of my answer. It's got to be with all my other polynomials. I got to bring it down. Difference of squares. Create your two sets of parentheses. In the first slot of each parentheses, I put the square root of a squared. So what's y squared? The square root of y squared. Y. So I put that in the first slot of each parentheses. What's the square root of 16? 4. So that goes in the second slot of each parentheses. And what are my signs? One's a plus, one's a minus. I now have three polynomials. 3y cubed, y plus 4, y minus 4. Can any of those be factored any further? They cannot. This is now factored completely. Questions on B? Questions on B? Can I erase and move to C?
Yes.
All right. Five z to the 4th plus 30z cubed plus 45z squared. Always look for what first? GCF. So looking at the coefficients first, what's the biggest number that goes into 5, 30, and 45? It's not 1.
5.
5 will go into all those, so I can factor out a 5. How many z's do we all have in common? Each term? 2. Each one has at least 2 z's. So I can factor out a z squared. Everyone okay with that? There's my GCF. 5z squared times what gives me 5z to the 4th? Z squared. 5z squared times what gives me 30z to the 3rd? Plus 6z. And 5z squared times what gives me 45z squared? 9. Everyone okay with factoring out a GCF? So I got two polynomials now. 5z squared, z squared plus 6z plus 9. Can either of my polynomials be factored further?
Yes.
Which one?
The z squared plus 6z plus 9.
Yep. Z squared plus 6z plus 9. Let's try to factor that using our T-chart. So create your two sets of parentheses. What goes in the first slot each? Z, that's the variable I'm dealing with. There's a plus sign in front of my C value. So what does that tell me about my two signs? Are they the same or different? Same. Since they're the same, what are they both going to be? Plus, plus. We okay with that?
Yes, sir.
Okay, T-chart. What goes in the first spot of the T-chart? 9. Second spot? Looking for two numbers that multiply to give me 9, add to give me 6. What's two numbers that multiply to give me 9? 3 and 3. 3 times 3, 9. 3 plus 3, 6. Are those the two numbers I want? Yeah, they are. So z plus 3, z plus 3. Can any of my polynomials be factored any further?
No.
Okay, let's write it a little nicer. How can I write z plus 3 times z plus 3? Z plus 3 squared. There's my answer. Now, if you left it like this, I probably would not count that wrong. Okay? We should generally, if we can, make it look a little nicer, do a little less writing. We'd put it as squared. Okay? Either way, it's correct. Questions on C?
Is that it?
Are we okay with those three?
Yes.
Not too bad?
Yeah.
Can I move on?
No.
No.
Here's another 2 more special factoring patterns. We had the difference of squares, right? Now we have the sum of 2 cubes and the difference of 2 cubes. So I would write these formulas down and memorize them. Sum of 2 cubes, difference of 2 cubes. So if I have a number or a term that I can take the cube root of, plus another term that I can take the cube root of, that's a sum of 2 cubes. And so it factors out to this special pattern. So if I have a cubed plus b cubed, I get a plus b times a squared minus ab plus b squared. If I have the difference of 2 cubes, so if I have a term that I can take the cube root of, minus another term I can take the cube root of, that's my difference of 2 cubes. That would factor out to a minus b times a squared plus ab plus b squared. There's sort of an easy-ish way to remember this. If I have a cubed plus b cubed, everyone look up here real quick. This sign matches this sign. This sign is opposite of this sign. Same thing here. This sign matches this sign. This sign's the opposite of this sign. This sign will always be a plus. Does everyone see that? So, same, different. Same, different. That's an easy-ish, maybe not so much way to remember it. So, they got a couple of examples next to each of them. If I have 64x to the third plus 1, I can take the cube root of 64x cubed, right? I can take the cube root of 1 as well. They're being added together, so that's a sum of cubes. So I would try to get my a value. How I get my a is I take the cube root of that first term. What's cube root of 64? Or 64x cubed, I guess. Cube root, not square root.
4?
What number times itself gives me 64? You think you said it?
4?
4. Cube root of x cubed.
You're losing me.
X.
Cube root of x cubed? Oh, okay.
So x times x times x would give me x cubed. Right? So the cube root of 64x cubed is 4x. That's my a value to plug in. Cube root of 1. 1. So my b value would be 1. So identify a and b. I can then plug those into the formula. So I get 4x plus 1. That's what they have right here. Times 4x squared would give me 16x squared. Minus a times b. 4x times 1 is 4x, so minus 4x. Plus b squared, 1 squared is just 1. So that's just me plugging these values into that formula. Does that make sense? Same thing in the second example. For the difference of 2 cubes, I can take the cube root of 27x cubed and the cube root of 8. So what's the cube root of 27x cubed? 3x, right? Cube root of 8?
Oh, wait.
2. So I could plug 3x in for a to my formula and 2 in for b to my formula. So I'd get 3x minus 2 times 9x squared plus 6x plus 4. And we will do some examples on our own. Okay? Are there any questions about these? These are our some more special factoring patterns, just like difference of two squares. Do we have a sum of two squares? No. We just have a difference of two squares, but when we get to cubes, we have a sum of two cubes and a difference of two cubes. So if you see two numbers, say I have x squared plus 4, that cannot be factored any further because I don't have a special pattern for the sum of two cubes. Okay? Or two squares, sorry. Everyone got it? We got that written down at least. Two examples here. Factor x cubed minus 125 completely. Can I take the cube root of x cubed? Yes. Can I take the cube root of 125? Yep. Is there a minus sign between them?
Yes.
Which special pattern is that?
Difference of,
Yep.
yeah.
Difference of
Square.
two cubes.
Cube. Oh.
Difference of two cubes, right? So I'm going to be using this formula. Right? Everyone recognize that we're using this formula. So now I just need to identify A and identify B. I do that by taking the cube root of each of my terms. So for A, I take the cube root of x cubed. What do I get?
X.
X. For B, I take the cube root of 125. What do I get? Huh? What number times itself gives me 125? 5.
Really?
Yep.
Lucky guess.
You're getting kind of good at these.
5 times 5 times 5 gives me 125. Yep. Now I can plug x in for A, 5 in for B to this formula. Everyone got it? So x cubed minus 125 equals, what's my A value?
X.
X minus, what's my B value? 5 times, what would x squared give me? X squared, right? Minus, or plus, A times B, what's x times 5? 5x. Plus B squared, what's 5 squared? 25. Can either of those be factored any further?
Yeah.
Can it?
Wait.
Do I have two numbers that would multiply to give me 25 and add to give me 5?
No.
No. Here's my answer. That'd be it. Everyone okay with that? Confusion?
No.
When you're using a sum of cubes or difference of cubes formula, that second polynomial will not be able to be factored further. Okay? That would just be it right there. We good? Can I erase and move to letter B? Yeah. Okay, letter B. Always, always, always look for what first?
GCF.
GCF. Do I have a GCF on B?
A.
Will 8 go into 54?
No.
No.
I think 56.
What's the biggest number that goes into 16 and 54 besides 1? 2. Does 16 go into 54? Nope. How many S's do they have in common? 2. So 2s squared is my GCF. Right? 2s squared times what will give me 16s to the 5th?
8.
8s what? Cubed. 2s squared times what will give me 54s squared? 27. Everyone okay with that? I now got two polynomials, 2s squared, 8s cubed plus 27. Can either of those polynomials be factored further? Which one?
The 8s.
How can I factor that one?
With sum of 2 cubes.
Sum of two cubes. Can I take the cube root of 8s cubed? Yep. Can I take the cube root of 27?
Yeah.
Yep, they're being added together. That's the sum of two cubes right there.
Yeah.
Okay? So I'm using a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Right? Do not forget about that 2s squared. That 2s squared will also be a part of my answer. Okay? So a, what's the cubed root of 8s cubed? 2s. Cube root of 27. 3. There's my a value. There's my b value. I can now plug that in to my formula, right? I'm going to go ahead and throw my 2s squared out front so I don't forget about it. So I get a plus b. What's a? 2s. Plus, what's b? 3. Times, if I plug 2s in for a here, what's 2s squared? 4s squared. Because you got to square the 2 and the s. Minus a times b, what's 2s times 3? 6s. Plus b squared, what's 3 squared? 9. Everyone okay with that? No?
No.
What's your question?
Nothing.
Nothing?
I just don't like it.
You don't like it? I'm sorry.
I'm just not fine with it.
Huh?
I'm just not fine with it.
I'm sorry.
That's 6S or 660
6s.
Okay.
Okay, I've got 3 polynomials now. 2s squared. 2s plus 3. 4s squared minus 6s plus 9. Can any of those be factored any further? No. It looks like that last one might be able to with slide and divide.
But we don't want to do
Right, if I slide the 4 over and multiply it by 9, that's 36, right? Are there 2 numbers that multiply to give me 36, add to give me negative 6?
Yes.
What are they?
No.
No, there's not.
After that.
Okay, good job. So, here's my final answer. Questions on B?
No.
Not too bad? Get those formulas memorized, and they'll help you. Can I move on? Factoring by grouping, this is the last concept for today. We factored by grouping before, right? For some polynomials, you can factor by grouping pairs of terms that have a common monomial factor. We've done this before, right? The pattern for factoring by grouping is shown below. We've already done factoring by grouping. I feel like sometimes these formulas may mess you up a little bit
Why is there an R?
because it's showing you that you have RA plus RB plus SA plus SB. If you group those together, you can factor out an R.
What?
That's like R would be a number.
Oh, okay.
Okay.
You lost me a long time ago.
Well, then let's just look at an example.
Why couldn't they just use A?
Okay. So factor z cubed plus 5z squared minus 4z minus 20. First off, do I have a GCF for all my terms? No.
No.
There's not a biggest number that goes into all those besides 1. They don't all have a variable in common, so I do not have a GCF, do I?
No.
We're talking about factoring by grouping, so how do you think I'm going to factor this? By grouping.
Yeah.
I'm going to group my first 2 terms together, my last 2 terms together. You okay with that? For my first group, I'm looking for a GCF. So z cubed plus 5z squared, what would a GCF of that be?
Where?
Z squared. There's not a biggest number that goes into 1 and 5 besides 1, so I don't have a coefficient out there. And then they both have 2 z's in common, so I pull out a z squared. Z squared times what gives me z cubed?
Z.
Z. Z squared times what gives me 5z squared? 5. We okay with that first group?
Sure.
Not too bad. Okay, negative 4z minus 20. What's the biggest number that goes into negative 4, negative 20? Negative 4. Do they have a z in common, or any z's in common? No. So negative 4 is my GCF of that second group. Negative 4 times what gives me negative 4z?
Five.
Z.
Z. Negative 4 times what gives me negative 20? Positive 5, right? Everyone okay with that? Do they both have something in common? What is it? Z plus 5. That's one of my factors when I'm factoring by grouping. What is my other factor?
Z squared minus 4.
My two GCFs, z squared minus 4. So I now have two polynomials after factoring by grouping. Z plus 5, z squared minus 4. Can either of those polynomials be factored further?
Yes.
Which one?
Z squared minus 4.
What is that?
You can square root them.
Very good.
Something.
Difference of
Squared.
squares. Everyone see that? I can take the square root of z squared. I can take the square root of 4. There's a minus sign between them. That's a difference of 2 squares. Not difference of 2 cubes. So don't write down that formula that we looked at earlier today.
No.
There's a difference of 2 squares. It's different than the 2 cubes. So z plus 5 is a part of my answer. Create your 2 sets of parentheses. What's the square root of z squared? Z. Square root of 4. 2. What are my signs?
Plus minus.
Plus minus. And now I have 3 polynomials. Z plus 5, z plus 2, z minus 2. Can any of those be factored further?
No.
Nope. This is now factored completely. Any questions about example 3?
No.
How we feel today about these notes?
Not difficult.
Not too difficult.
I expected it to be difficult.
This one?
I still don't understand what the R
This one?
means.
That's just showing that it has a GCF. R would be the GCF of that first group. S is the GCF of this second group. So they factored out an R, factored out an S. So one of their factors is what they have in common. Second factor is the 2 GCFs.
I was like locked in.
okay.
for
Right.
just 10
I get it
minutes,
now.
Okay.
And then you lost me.
Does this example make sense?
Yeah.
Okay.
Because it's old.
Think
We're
about
good
that.
at numbers.
Think about that.
We've been
Don't.
over this, right?
Huh?
We've been over this, right?
Yeah.
Yeah.
Okay. Questions on example 3?
But you had me for the first 10 minutes, and then I just kind of
Here you go.
drifted off.
Page 194, 6 through 30 evens. So we do Tuesday. The 25th. On, do what? Yeah, it is. Are there any questions about my notes before I end the recording?
That's my birthday.
25th?
Nope.
Okay.